today's topic is not about data vault in general, it's about machine learning, because your data vault is definitely the place for machine learning, since machine learning is all about data. The reason we created this presentation is that a lot of people are a little bit panicking about machine learning, and I understand why, because it is a broad area. So it actually needs a lot of different kind of skill sets. So it's not just about data, it's about many other things as well. But the main thing is data, and that's something that you already know, I'm sure. So we are trying to explain you how this will be easier to start with machine learning, and you don't have to have any panic about that. So my name is Heli. I have graduated from University of Helsinki with a master's degree and currently working on my doctoral studies, surprisingly related to machine learning. I have been working with Oracle products for many years, and that's why we chose Oracle as the technology for this presentation. You could use any other technology as well. So what we are explaining today are ways of doing machine learning without actually having to do everything yourself. And also other providers have this kind of tools, so not just Oracle, but we will introduce Oracle tools because those are the tools we know the best. Anything to do with data and databases is very close to my heart, and that's why I found machine learning as well. So I've been talking about database designing for very long, and now I have added machine learning to that topic as well. So I've been talking about machine learning for about 10 years now. I'm a CEO for Miracle Finland, Oracle ACE Director, which is an award from Oracle given every year to those people who they see are contributing to the community with knowledge. I'm 3 times certified for Data Vault 2.0, so I know a little bit about Data Vault as well. I'm a public speaker and author. Well, I'm a Finn, and people know Finns are very quiet, but obviously I'm an exception here, so I speak a lot. And I have written some books as well. The first one about database designing, then something about SQL and PL SQL, and then the latest 2 ones are about machine learning from different points of views. And I'm here joined with my colleague and son, Matias.
Hello, my name is Matias, and I'm the son of Heli. So I've been in IT since birth, so I know a lot of this. So I've been professionally doing this for about a year, a bit over a year. And I love learning about cool stuff, so this is the field for me because there's always new stuff here. And I've been doing like OCI, which is Oracle Cloud Infrastructure, and learning about networks and IoT devices like Raspberry Pis and stuff, and machine learning and analytics. And every day I can add new stuff to the list.
So today's topic is machine learning. So example about the process of machine learning. So it starts with defining the task and understanding what the task is. Task means what are you going to do with machine learning? You are trying to find the customers who are about to leave your company. You are trying to know what's the temperature next Friday in London, and you're trying to predict something. So what is it that you want to achieve with machine learning? Then you collect the data that supports this task, and you understand the data. Then you go through all the attributes, the features, the columns, all the elements of your data. You prepare the data, and you do a lot of transformations for the data. You create models, you evaluate models, you score, you deploy, and afterwards you even monitor the data and the models. So there's a lot of things that you have to actually do in machine learning. In other words, actually, you do exploratory data analysis, data visualization, feature selection, feature engineering, and many other things. So it's plenty of new words that is a little bit confusing. And that's why we were thinking we will give you 2 shortcuts today. The first one is called AutoML. So that's a process of machine learning automated by, in our example, by Oracle. And the other one we talk about is AI services, which is a service for certain use cases that you can just call and achieve a lot of things with machine learning. But let's see what that is. First, we talk about AutoML, and I'll let Matias explain you a little bit more about this.
So what you need to do is some AutoML. You need to go to OCI, Oracle Cloud Infrastructure page, and make an account there. You can make a free tier account, which is free. You don't have to pay anything, but you do have to put your credit card there. Well, it doesn't charge you anything.
And that is a proof case. We have tested this many times. So if you build it as a free tier account, you are not charged ever. And it's there for as long as you need to use it.
Yeah. And after that you have made the account, what you need to create is an autonomous database and a user for it. And to make a user, you can either choose the database actions or the machine learning user administration. And in the database actions, you need to click on the OML to enable the machine learning part for the user. And after you have made it, you have logged in. You can, in the database actions, you need to pick the Oracle machine learning part, the development tool, and you need to log in with the user you have just made. And you need to take the URL, or you can take the URL save somewhere, because it's an easy way to get back here. And after you're logged in, this is the interface you see. There's a lot of things here, but what we're going to talk about is the AutoML you can see on the bottom left. And after clicking it, you can see your previous experiments, if you have any, or you can create a new one here by clicking on the create. And after that, you can give it a name, some comment to know what it's about, and you need to give it a data source, which can be a view or a table. And you need to give it a target to predict, some prediction type, and a case ID. And in the additional settings.
So the prediction type, there's two possibilities in this tool. It can be classification, it can be regression. So Matias, what is classification?
Well, classification and regressions are like different kind of things you're gonna predict. And if you want to predict like what's the weather gonna be today, the degrees,
that's regression.
That's regression. And if you want to get like yes or no answers to something, that's regression.
That's classification.
Oh, that's classification. Yeah, that's classification.
So in here, you select the data source. Where is your data? Is it in a table or is it in a view? And if you have several tables that you need to use, you need to create a view before you can do anything, because you can only select one here. The prediction target is the column or the feature that you are trying to predict. Like Matias, you just said the temperature, for example. And then based on whatever the prediction type is, if it's number, most likely this is going to be regression. And if it's varchar or any kind of chart type, then it's probably classification. And that's selected in prediction type. Of course, you can change it as well. So the case ID is the identification of each row in your data set. So that is not mandatory, but you can choose that if, for example, you're doing classification, it might be very useful. So Matias, what is additional settings?
In the additional settings, you can pick up the maximum top models you're going to use. In the models, the duration of how long it's going to run, and the service level, you either pick low, high, or medium, and difference is mostly on if it's going to do some parallel tuning or not.
Parallel querying.
Yeah, parallel querying. The high, of course, does it a lot, and the low doesn't even do it. And in the model matrix, you can pick on balanced accuracy, or you can pick on faster results. The balanced accuracy
or any other metric that is available in this particular tool. There's plenty of different metrics available, but balanced accuracy is quite often the best one, because if you're not familiar with machine learning yet, this is not something you should be thinking too much. The metrics depends on the data set you have and also what you're going to do with it. Like if you are trying to predict people with cancer, the metrics might be different than if you're trying to predict if a meteorite is hitting Earth. So depending what kind of thing you are trying to predict with machine learning, the metrics can be different. But in very safe choice is usually balanced accuracy. It is something that it's easy to start with.
Yeah, and in the right column, you can pick up the algorithms you're going to use, which are better for your data set.
And these depend on your Oracle version. So in Oracle database version, there's always new algorithms in a database. So here's some examples that we have in this version that we are using in the demo.
And if you're doing a regression type of model, it's almost the same, but in the model metrics, there are some differences.
Yeah, and the reason for that is that in classification, we are trying to predict exactly the right classification. But in regression, we are trying to get as close to the exact number as possible. So if we think about the temperature next Friday, it actually doesn't matter if it's 25 or if it's 25.1 degrees Celsius. It's about the same. So we're trying to find measures and metrics that will tell us how close are we to the accurate value. So the metrics are a little bit different than in classification. So mean squared error is usually an easy start when you start building your models. And the algorithms, they might be the same or different depending on the use case. But here we have some same algorithms as we had for classification, and some are different. These are the features. So Matias, you have here a target. What is a target?
The target is like what you're trying to predict, what's like most close to it, and what you're trying to do there. And there you can see the different type of features they're going to use for it.
And for each feature, like this is like a column in a table or view, you can see the data type of it, how many % of nulls, what else can you see here?
You can see the minimum and the maximum value, the mean and the standard deviation of value too.
So this tells quite a lot about your data set, which is important.
Now, after you created the experiment, you can give it a better name, or you can click on the start and pick faster results or better accuracy. Better accuracy does more hyperparameter tuning, and the better accuracy does it more faster. And the better accuracy, sometimes it can be more like accurate. The faster results is more accurate than the better accuracy.
Yeah, sometimes it can be that. Well, because the faster results is using kind of preset hyperparameters, and it's not trying to tune them as better accuracy is trying. Sometimes it finds better hyperparameters, sometimes it doesn't. But anyway, we choose faster results because usually we get good enough results with that. And it is faster, as the name says.
And after you run it, here you can see the results. And in the leaderboard, you can see like the algorithms used and the models, what you have made for them. You can see the balanced accuracy score for them.
So Matias, what is a model?
Model is like, it's the algorithm used and the thing made for the algorithm, like what is about. And for the data, it's like how it did for the data.
Yeah, so it combines kind of the algorithm and the data, and that builds a model. So each algorithm uses the data and builds a model. And this balanced accuracy here, so the list is ordered by the balanced accuracy because that's what we chose as metrics for here. I will skip this and I'll let you explain this one.
And here you can see the list of additional metrics. And after you have run it, you can also pick some more for it. And you don't even have to run it again. So if you decided to have more metrics for them, something that's more closely to your data set, you can pick some more metrics for it. And you don't have to run it. And then you can rename the metrics, the models, because they don't have to be like named like the code, and give it a better name so you know better them.
Yeah, it's easier to find them because all these models, they are database objects, just like a table or a view or whatever. So they are stored in a database with the name that this program gives them. So you can rename them for a better,
or easier use in the future.
Yes. And here we can see how it's been named and how we have different kind of metrics available as well, depending what we chose earlier.
Yeah, you can also click on the name, and here you can see the prediction impacts on like how the different feature impacts on the model, the results, and you can know your data better, see some metrics about it, and you can also see the confusion matrix, which is a powerful tool. You can see the quality of your data and see how well it runs.
Yeah, how well actually the model is using the data, how well it's predicting. So like if we're trying to find the cancer patients, it's important to find every patient that has a cancer potentially. So it's much more important to find all those patients, and it doesn't matter if we have some extras in there, but it's very, very bad if we don't find one patient that has a cancer. So depending on the use case, this is read in a way that you know if the model is good or not.
And also the models, they're already stored in the database, so you can call them with SQL or PL/SQL, and makes it kind of easy.
So what if I don't want to use them from the database with PL/SQL or SQL? Is there any way I can use them outside of the database?
Well, you can deploy the model just clicking on deployment, and after that you can call them with like REST APIs and stuff like that outside the database anywhere you want.
So if I deploy, I just press deploy, and then what do I do then?
You can give it a better name. You put a URI there, your version, the namespace, and just deploy it. And you can click on the shared button, so it's shared outside the database.
So other users can also use it,
yes.
Call it.
And after that, you click on the hamburger menu on the left, and you see the models. You click on that, and you can see the deployments there. And these are the models you have deployed. And clicking on the name, you can see some metadata for it, some specifications, and how you can call it with REST APIs.
Oh yes, that's here. So so the API specification. So what is the specification? How does it look like?
Yeah, the specification of the deployments.
Yeah.
And you can also create a notebook from it. And you can find the notebooks in the same menu. And when you open that, you can see like how it has been made with Python and how it's going to look.
And also in this notebook, so here you can see this percentage Python. You can also have here percentage SQL if you want to create SQL blocks, or you can have percentage script if you want to use PL/SQL, or you can use percentage R if you want to use R. So there's several languages you can use here in one notebook to just create your machine learning process. And this is also a good way to learn Python, actually, if you are not familiar to Python, because it has created you the whole notebook here. It's using Oracle's own OML libraries that are used here. So this is kind of what AutoML is about. So it automates the process of machine learning. So you only select things and you tell, build me models, and it builds you models, it evaluates them automatically, and deployment is very easy and simple. I hope that gave you a picture about AutoML. And as I said earlier, this is not Oracle specific. Also, other providers have this kind of tools. So we just use Oracle as an example here. Another kind of shortcut is AI services. So AI services are pre-trained models, and they are for a specific use case. And you will see in the examples what that means. They are trained and maintained by Oracle, so you don't have to train the model and you don't have to maintain the models. They are there and they are taken care of. You can use these models with your own data. You can also train them with your own data if they are not working well enough for your use case. So let's go and see. I will do, hopefully you will see this one now, where I will do a live demo so that you can see how it works. I'm sure you already had enough slides for a while. So we start with language. Language AI service is about written text. So I can do text analytics. So if I take because I, of course, don't trust Larry. He has put here his demo, which of course works. I don't want to use that. I want to use my own text. So I just copy pasted here a text. By the way, here's a prerequisites that you can just check to be sure that you are able to do whatever you want to here. So it will tell you that you have to have these policies and so on and so on. Very simple. So anyway, here I have my text and I will just say analyze. I can also choose here a different language, or I can say that I don't know what is the language. I let you decide and try to find it out. But now I know it's English, and I was correct because it says it's a 89% sure that it's English. So it says it's English, and then it tells how sure it is about this guess that it is English. I'm very happy because this is a piece of my book, and I'm very happy that they find it as English. It might have been like Jeopardy as well, but it finds it English. And then it says there's a text classification as well. It says computer and electronics or software. It's about 60% sure about that. Well, this is about computers and software, but anyway, 60% is better than 40%. Then what also does is named entity recognition. So it has these colors here that will say this red one is product, blue one is organization, yellow is location, green one is quantity, and so on. So it finds different kind of entities from this text, and it tells this one is a product, and I'm 93% sure about it. And this one is a product, I'm 98% sure about it, and so on. So it finds named entities from the text. What it also does, it finds key phrases. So like here it finds book, and it's almost 100% sure it's book. It finds business operations, it finds security, OCI platform, data science tasks, and so on. It also does sentiment analysis. So it makes in the whole document, in this document, it finds it's neutral, and it's 90% sure it's neutral. Then it also does aspect-based sentiment analysis, and it does a sentence level analysis. Here it's having each sentence and then giving if it's neural, positive, negative, or mixed. This is very neural, which I'm actually very proud of because this is supposed to be the marketing text of the book. So I'm not over marketing the book. I'm very neutral about explaining what the book is about. So that's good. I like that. It also finds personal identifiable information, PII information from the text, which can be very useful for some of your tasks. So you need to find PII from a certain set of text, and you can use this tool for that. The good thing about these tools is that you can use the result of this outcome as an input to the next process in your company. Like, for example, a simple example. Here, it recognizes it as English. It could have recognized it like Finnish. And you would like to, this is, let's say a customer is complaining. So this service will tell the customer is unhappy and makes this unhappiness known in Finnish. So you could just have a process that gives to the customer service who knows Finnish and is capable of talking to an unhappy customer in Finnish. So you could use this to have your processes automated, for example. So this is what you can do with one of the services. Another one is text translation. I'm going to, of course, use Finnish because that is a very known language globally. So I'm going to put here some Finnish text, and I'm going to say this is Finnish, and please translate it for me. Well, I'm sure you all know French, so this is probably very easy for you, but just in case you don't, let's put it in English. So I have a text in Finnish here that I will translate to English. This is a children's book about Pippi Longstocking, and it even knew the name of Peppi Pitkätossu in English. So it's not just translating, it also knows something more. But since I'm sure you don't trust that this is true, I'm going to make it, let's put here like this, and I will change it to English, and then I will put it to Finnish, and I will translate it to the other direction. Now it made a mistake here because it was not able to find Peppi Pitkätossu again, so it used the English name here, but otherwise it's making pretty good translations also to Finnish. And I can tell you Finnish language is not very easy to be translated to or from because it has a very strange grammar. But this is doing pretty good job with that. Well, this was one of the examples about these services. I will have the slides here so you can go and check yourself if you want to do that. But what I will, and you can have everything in JSON. So all the results are in JSON if you want to put the JSON to the next process, possibly. You can create your custom models as well, but I don't talk about that now. I will talk about speech. So language was about written text, while a speech is about spoken. So I made a test here with my broken English. So I started the job. So every time you have a new use case for your speech service, you create first a job. For that job, you have to define certain things like the compartment, like the bucket, where to find the file and so on. But you need to have a file that has the spoken part of your data. In here, you can choose, you can also have it as SRT transcription format, which is the subtitles. So if you want to have the speech as subtitles, you just select here, get SRT. And you can also enable punctuation, which means that every time the service thinks that there's a period, it has a punctuation. Well, I will show you what it means. Well, I have my file here that I will give it, and I will start my job creation using that file. It's creating it, and when it's done, it shows it as green and succeeded. What I have here now is a file that has the results. I can also have it as JSON, but this is the file. Hello, I'm testing this service now. So how does the voice stir this work? This is a very brief demo. I am very sure this is not what I said. So obviously I was not pronouncing it very clearly. So I was speaking like very unclearly. So I tested again. I made a new file, and this time it worked. Hello, this is a brief demo about the voice service and how it works. So I get a transcription results as this. So it shows what was in the text and so on and so on. I don't go in details with this, but it has tokens. So each word is a token here. And it also has the punctuations about it. The vision service, this is something I want to demo again so that you will see how it really works. I take vision from here. And there's several things I can do in vision service: image classification, object detection, text detection, and document AI. Let's see. Image classification. Again, I want to use my own files. I don't trust this. I want to have my own. So here I have a slide where I'm presenting in Germany. It sees there's a person, clothing, poster, man, okay, good, curtain, and so on. So it finds things from this picture. If I use object detection for the same picture, it now finds the same things, but it marks them as well. So there's a person here, and there's a hat. Well, I don't have a hat here. So obviously it's not 100% accurate, even though it thinks so. Let's test with another one. So here I'm in Sweden with my Swedish friend Matias. It's finding all kinds of things like footwear, glasses, person, and so on. But see, here I have a coffee cup in my hand, and it says it's a camera. So in case I'm building a model that tries to figure out if there's any coffee cups in the picture, this model wouldn't work. So I need to go and further train this existing model to realize that this is not a camera, this is a coffee cup. And in that case, I could just create my own project here and use this model to further train it to understand my camera. My camera is not a camera, it's a coffee cup. So you can very easily do that kind of further training for these pre-built models. So what is text detection? If I have here a picture Let's take the same picture you already know. So here I'm presenting, and there's a lot of text in the background. So it finds this text, why in database, why to move the data, and so on. These are the lines it finds, but I can also ask for words. So now it's finding just the words from this picture. So it finds words from a picture. Then we have a thing called document AI. Let's give it a try and have a Finnish document. I have a receipt from a Finnish grocery store. I give that and it analyzes and it finds that it's a receipt and it's 100% sure, but it thinks it's English. The reason it thinks it's English is because it doesn't know Finnish. So this service hasn't learned Finnish yet, but still it's actually doing a very good job. It finds the text from here. It finds key values very well. And as a table, it can show me what I have been buying from the grocery store. So even though it doesn't know Finnish, it can still work on it, which I think is really good. So that was a vision. So vision is about images, about pictures. These are the things we just talked about. Then the custom models, as I mentioned about the coffee cup use case, you can just build your own custom models. Here's an example how to do it. I don't walk it through, but I have it in the slides if you want to do it yourself. Then we talk about document understanding. So I go here again, analytics and AI and document understanding. So as you can see, these are all different use cases, and there are models for those use cases. So you wouldn't use a language model for any speech, you would use speech, or you wouldn't use a speech model for written text and so on. That's what I meant with the use cases. So here we have text extraction. I'm going to use the demo one now. So we have here a document, and we are extracting text from that. And it's now analyzing, and it finds lines and it finds words from this particular text. And I can also download it as a searchable PDF if I want to. This one is an image now, but I can download it as a searchable PDF. Table extraction, like here, I have a partnership agreement. And in this agreement, I have a table it finds from the long list of text. It finds this one particular table and it shows to me. So this is the table. By the way, there's always the request example and the response, the example, if you want to call this using REST API. Then key value extraction is finding key values from the example text here. So this is again a picture. I have an invoice here, and it recognizes it as invoice, and it's very sure about it, and it finds a lot of important information from there. And I can also use my own local file. Let's use my same receipt here. And I haven't even called it receipt. I have called it Kuitti in Finnish, so I'm not giving any kind of head start for this tool, but it still knows it's a receipt, and it finds information from it very well, even though it's in Finnish. Then there's a thing called document classification. So that's actually something we already did earlier. Many of these services were able to find out if it's an invoice or if it's whatever it is, but this is especially doing that. So it's finding out this is a bank statement. And if I use my own file here, oops, it's finding that it is a receipt. So this is what a document understanding is doing. So what we also have here, these are the ones that we walked through, is an anomaly detection. Anomaly detection means that we are trying to identify rare events or observations, things that are very different from maturity of the data. Well, how do we know if it's different from the maturity? So like here, for example, this one star here, it looks like an anomaly. It is different from all of the rest. But how do I know it is anomaly? It could be just normal data, like our sales is every May we sell a lot more than we sell in the rest of the months. It could be very normal. So how do I know that? Well, I have to teach my own data to the model. So the model knows what is my normal. For that, I am training the data with a data set that does not include any outliers. So I am trying to teach the normal to my model. The training data should teach the normal situation as well as possible. So it should have all kinds of examples of the data and no outliers, because we are teaching the normal situation here. If you run into problems with this tool, it's probably with the data. So your data is not in the format that it's asking. It's telling you very detailed how the data should be built. So maybe you didn't follow all the orders, or maybe you don't have enough data, or maybe you don't have all the privileges that are needed. So read carefully at the instructions. They are shown in the tool very, very clearly. So in anomaly detection, what we do, we have the data. We create a project, we create a data asset based on the data, and then we create and train a model. And then we can do the anomaly detection with a new data set. So how it's done? Well, here we create a project. By the way, here are the prerequisites. So study that carefully before you start using this service. This is a little bit more trickier than the ones I showed you before. So I create a project. I need a data asset for that. So I create a data asset. The data can be located either in Oracle Object Storage, Oracle Autonomous Database, or InfluxDB. So these are the data sources that are available for the tool. Then I select my training data from this bucket that I chose here, but it could be whatever, something else as well. And then I create and train the model. So I have a project, I have a data asset, and I'm creating and training a model. Here we go. There's only two things I can define here. I can define target false alarm probability, FAB, and I can define training fraction ratio. Nothing else I can do here. So the only thing I do, I create a data set that includes all my normal, and I might want to define these two things here. Everything else is done automatically. I don't do anything. And it's creating, and finally, when it's done, it's showing green and showing active. And now I'm able to detect anomalies using this model with a new data set. So when I start detecting with a new data set, I have to have the data set in a file. So I say here, select file. I select my own data set and I say detect. It will show me in very detailed and for each individual feature and the features combined if there are any anomalies. So like if the temperature in one corner and the other corner combined together is somehow strange, it's usually they are very close to each other, but in one point of my data set, they are very distant. It will show them as a possible anomaly. So it compares the estimated value and the actual value to each other. And if they are distant, if they are far from each other, it shows them as anomalies. This is very intuitive tool. Everything is like in charts or in graphs. So it also has everything in JSON as all the other tools here. So JSON is kind of the common element here. But then one more thing I want to explain to you is data labeling. So data labeling means that when you are doing supervised learning, so there's unsupervised learning and supervised learning. Supervised learning is about known data. So you already know the input data and the output data. You know what is the correct answer. And you use that knowledge to train the model. In unsupervised learning, you don't know. You just give data set to the model and ask, give me something from this data set. But in supervised learning, you know what you want. You want to predict the temperature for next Friday, or you want to predict if the customer is about to leave my company. So you need to have labels. So you label your your properties or your data sets. And it's a little bit difficult if you have images, text, or some kind of complex things. So how do you label these? What if you have single or multiple labels? And the thing is that if you have you want to further train the AI model, that let's say the coffee cup example, you might need to have some images where you have labeled this is the coffee cup, so that the model learns what is a coffee cup. And that's why you want to create a new labeled data set for the model to learn about coffee cups. So for that, in OCI, there's a thing called data labeling service. It's for images, text, or documents that you can use. You can label them and then use them for further training. It starts with creating a data set. It could be image, text, or document. Then in this example, I chose it's going to be image, and I can have a single label, multiple label, or object detection. I can have a local file, or I can select a file from object storage. And here's what I have. I have pictures, and I have decided I want to label these as a man or a woman, depending on the picture. So I just add labels, man and woman, and then I will add these labels. And if I realize I should have the third label as well, I can just add the third label and use that as well. When the labeled data set is created, it's existing here. So it's a data set that I'm able to use now for labeling. I just select my data set here and I say label. It opens me the first file, and I can just select which label I want to have for that, and then go to the next one, and so on and so on. I can also do more complex ones, like this one is having several labels. This one has a mouth, a nose, and eyes. I can just select one piece here and say this is eyes, another piece and say this is nose, and the third one and say this is mouth. So this is how I can create a data set that can be used to train my models. You can export the data set, and you can use it somewhere else as well. So these were some of the examples that are available in the Oracle Cloud, and similar tools are available also in other providers' tool sets. What we talked about today was the language, speech, vision, anomaly detection, and then we talked about labeling. There's more same kind of AI services coming to this Oracle tool. For example, forecasting. But the thing here is, as I go to conclusions, is that your job is to find the data and prepare it so that you can use it with machine learning. So that's your job. And as I assume that's what you have been doing so far already, you've been playing with data a lot. So this is not difficult at all. You will manage it very easily. And then in our example, Oracle takes care of the rest. AutoML or AI services, you provide the data and Oracle provides the rest. So there is really no need for panic when we talk about machine learning, because there are so many good tools available nowadays. You don't have to start from scratch. You can start from using a head start here. And there's plenty of solutions to make your life easier. These are just some examples that we showed today, but there's plenty of others as well. I'm sure you know about ChatGPT and so on. So there's plenty of different kind of tools for different kind of use cases. Today, we talked about AutoML and we talked about AI services. And there is definitely more this kind of tools coming and already came. So I really encourage you to start with machine learning, and preferably start today. Because the thing is that you actually might like it. If you like data like we do, I am very sure you will like machine learning, because it's all about data and finding interesting things from the data. And in your data vault, this will bring you a lot of knowledge about your business. So absolutely start with machine learning. It is fun.